My name is Matthew Patrihay. I'm a computer engineering student at Purdue University and part of the team that built the world's fastest Rubik's Cube robot. What's always fascinated me about the project is how cool and visually impressive it is. From the very beginning, when I first learned about the record in about 2018, a previous world record holder, a team of grad students at MIT, their project really inspired me, and I thought to myself that someday I'd want to try and beat the record myself. And so here I am today, and really pushing the boundaries of the record and cutting it down by about a third of their time.
So when Matthew first reached out on LinkedIn, the first thing that he asked me was, hey, I need some help. We want to solve the Rubik's Cube. We want to break the world record, and we need Kollmorgen's products in order to do it. And we talked a little bit more about his goal, and we recognized that it was a bold and exciting challenge that would push the boundaries of motion control. And it's the kind of project that aligns perfectly with the strengths of Kollmorgen's technology.
So how I found Kollmorgen was a very analytical and quantitative approach. We always knew that we needed high speed, high acceleration, and high torque, with low rotor inertia specifically as well. So we ran a bunch of numbers to determine our load scenario and looked at a bunch of different motion systems across the internet, and we found that the 2G motion system was our best option to go with.
The 2G system is tightly integrated. Each component works together to minimize latency and maximize throughput. It's powerful, responsive, and user-friendly. That combination was essential for Matthew's team's success.
As soon as we start the timer, we have to take a picture of the cube, process that picture, do a color recognition to determine the initial state of the cube. Then once we determine that initial state, we send it over to a solver, which generates all the moves we need to perform. Once we have those moves, we send it over to the PCMM, 2G, to optimize the motion control system and determine how we're going to perform those moves. After that, we execute the motion and perform all the necessary turns to solve the cube. Once all that's done, we stop the timer. Corner cutting is being able to start one turn ever so slightly before the previous turn is complete, essentially being able to smoothly transition from one turn to the next. And that transition saves just a few milliseconds, but if you compound that over about 15 to 20 turns during a solve, it adds up quickly. In order to achieve the accuracy required for corner cutting, we were able to utilize the 2G product line's support for EtherCAT. The very fast cycle times allowed us to know the precise position of every face at every moment, with cycle rates as fast as 250 microseconds. Having a partner like Kollmorgen was essential to the success of the project. It really allowed us to push the boundaries of what was possible and achieve our goals.
In the end, with their mechanical design and control strategy, they built something that truly leveraged the strengths of the Kollmorgen system. Their ability to harness performance with off-the-shelf components was exciting to witness. This achievement is a perfect example of engineering the exceptional.